In this example, we are asked to solve the equations for x. So considering part A first. In part A, we are given 2 times the absolute value of 2 minus 4x is equal to 50. So the first thing that we need to do here is start by isolating this absolute value by dividing both sides by 5. So we're left with the absolute value is equal, or the absolute value of 2 minus 4x is equal to 10. So since we have the absolute value on one side, we can now rewrite this in the equivalent solution set form. So we have 2 cases here. Our first case is 2 minus 4x is equal to positive 10. Or we can have that this is equal to the negative case. 2 minus 4x is equal to negative 10. So to solve this equation for x, we need to think about each case separately. So case number 1, so subtracting 2 from both sides of the equation, we have negative 4x is equal to 8. And then dividing both sides by negative 4 leaves us with x is equal to negative 2. And very similarly in case 2, in case number 2, we're going to start by subtracting 2 from both sides again, leaving us with negative 4x is equal to minus 12. And last but not least, dividing both sides by negative 4, we're left with x is equal to positive 3. So these are the 2 solutions to the absolute value equation given in part A. Now, in part B, again, we're being asked to solve for x, but here we have 5 is equal to 6x minus 7 plus 9. Now, again, the first thing that we need to do here in order to solve is to isolate the absolute value. And we can do this by subtracting 9 from both sides. Now, we'll pause for a cause here. Notice that we have the absolute value of 6x minus 7 is equal to negative 4. So this is danger. Right? We know that absolute values are supposed to be non-negative. So we cannot have an absolute value being equal to a negative like this. So we can observe that therefore there is no solution to this absolute value equation. Again, we know that there is no solution here because by definition, absolute value equations must be greater than 0, greater than or equal to 0.